one and all present here. Am I audible?
Yes, madam.
Yeah, you are audible.
Yes, yes, sir. Thank you. Good evening, everyone. A very warm welcome to one and all present here for the third session for the day. It is a great pleasure to introduce today's speaker, Dr. Gopal Pardesi, a highly experienced academician with over 35 years of teaching experience and more than 10 research publications in national and international journals. Gopal sir holds a PhD in information technology and is a member of professional bodies such as IEEE and ISTE. With strong expertise in agentic AI, generative AI, advanced machine learning and deep learning, blockchain technologies, machine learning operations, data operations, and ICT, Sir has been actively involved in teaching, research, and faculty training in emerging technologies. Gopal sir is well known for explaining complex concepts in a simple and practical manner. Passionate about teaching and continuous learning, Sir inspires curiosity, innovation, and critical thinking among students and faculty alike. We are delighted to welcome our speaker, Dr. Gopal sir, for the session on generative AI tools in chemical engineering and look forward to an insightful session. Over to you, Gopal sir.
Yeah, thank you, Prasida. You have given me a big responsibility on me that you explained that I am expert in making the things more simple and all that, right? But this
Yes,
chemical
yes, sir.
technology and chemical processes are there, they are very complex and all that. So I'll try my best to optimize the things, right? So that each and everyone can understand. First of all, I would like to congratulate the chemical department, the whole chemical department, right from Nita Mehta ma'am, the HOD, and all the faculty members who are involved over here, right? As sir has also said that this is the time we should move from this, we should learn what is happening in the marketplace and all that, right? So it's a very novel thing that the chemical department, they organize a FDP at faculty training program, or there may be students also, because the number is around 75. It's a very huge number. That too on holiday, right? Today is a holiday declared by government and all that. So I'm very proud about that, right? So thanks for inviting me, giving me an opportunity, right? So I'll try to give justice to whatever comment or whatever you have said just now. So let me start, because now the responsibility given to me is I'm supposed to discuss some chemical processes, right? Or how agentic AI can be used for chemical industry and all that, or chemical departments, basically chemical industry, right? So, so based on that, I may explain. Yeah, I have planned to explain three applications where, for example, generally say chemical process optimization, right? Then new drug discovery. That day somebody told me that ma'am has asked him, I think Sagar has told me, ma'am has asked him to give some lecture on new drug discovery and all that. So if time allows, I'll discuss that also. The third thing is I may discuss or I will discuss how catalyst can be new catalyst can be generated and all that, or how new catalyst can be developed so that the chemical reaction become faster and all that. Now you all being from the all are from the chemical field, right?
Yes,
Mostly.
sir.
Yeah.
Mostly.
Okay. So there is no point, means wherever the chemical process comes into action or into my discussion, so there I will not explain that in detail and all that. So I'll try to stick on the either the AI form, right? Now, just with this brief introduction, I think Elizabeth ma'am is also there. Then uh, okay, so nice to see Elizabeth Joseph ma'am here, and one more faculty was there. Right. So anyhow, so I'll start with this. So if so, topic name is let me share my this thing. Uh, I'm sharing my screen right now. So Prasid, help me somewhere if anything goes wrong and all that. Right. So I
Sure,
hope
sir.
that is properly visible.
Yes, sir. It is visible. We can see.
So this is the topic which I want to discuss today, or I want to just analyze this, right? Or I want to profess this or explain this or discuss this with you and all that. So agentic AI driven autonomous catalyst discovery. Now you all know about what is catalyst, right? And then how agentic AI can be used for that, right? So for that, now I think today is the third day, 12, 13, 14, 15. So this is the fourth day. So you might have heard, was it AI and all that. In fact, Thampi sir has also explained this in the keynote address, right? What is machine learning, deep learning and all that. So what we'll do, we'll go step by step as Prasiddha has explained that generally this is my method, or I, while teaching anything or discussing anything, I start with the topic itself, right? And I dissect the things in a very simple terms so that the layman can understand it. Now we'll talk about agentic AI later, because right now, if you ask anyone, right? So I discussed this with my students also कि अभी क्या चला है, तो जैसा वो ऐड आता है कि अभी सर फॉग चला है, नो अभी क्या चला है. So now new fog is there, right? So that some spray and all that, body spray and all that. Similarly, if you ask me what is going on in the AI, so today morning only I received one call from one of my friend's daughter. She is not getting placement and all that. She has done B in CS, computer science and all that. She's from Pune. So Pune University, generally, a lot of opportunities are available in Pune and all that. And their syllabus is also good as compared to, or more rigorous as compared to Mumbai syllabus, right? It is more practical oriented and all that. But still, the students are not getting, or she has not got the placement and all that. So I asked her, what you are prepared. This slightly from the, because everywhere AI is there, right? A lot of disruptions are there in this AI. Because of this AI, a lot of disruptions are there, right? So I just asked her कि भाई आपको क्या आता है and all that. She told me that I know some basic about this AI. AI was her elective, right? She said that uh, क्या बोलते हैं हमको, specialization in AI and all that, right? So major was this and minor was AI. So when I asked her about what is machine learning, which algorithms she has studied, she said, no, sir, I have not studied machine learning and all that up to that detail. That was your minor, so you should know in detail. You should know the practical things. You could have done at least minimum 5, 6 projects on that, right? So this is the situation of the most of the, say, computer science students also. So now you can imagine the chemical, because chemical being a separate field and all that, but still everywhere this AI has come, right? Everywhere AI is there and all that. So AI is an integral part of now engineering. AI is an integral part of uh, any new innovation and all that, right? People are doing every day. There are a lot of disruptions. That too, people are talking of agentic AI and all that. So if you ask me what is going on right now, so machine learning is almost obsolete now. Deep learning, people are using it, but for specific applications only. Then from that, then generative AI came. Now people are doing to agentic AI. Everywhere agentic AI is used and all that. Few days back, you might have, my slides are moving, right? Prasida, my screen is changing, na?
Yes, sir. Yes, sir.
Yeah, okay.
Yes, sir.
So what I meant to say is, I meant to say this. So first, let me talk about this one. So this is our AI universe, right? Very nice GIF, right? In 1970s and 1975 and all that, people used to talk about AI, artificial intelligence, right? And then one new meme has also come that AI to abhi aaya hai, but WI was there long from, right? So human intelligence is there, but AI, artificial intelligence is also there. Now it is developed, it is getting evolved, right? Day by day it is evolving and all that. 3, 4 days back, those who are aware about the LLMs and all that. So then one big news are there in the tech world, that the guy who has written, the Boris, who has written the Anthropic Cloud AI, right? Because there are a lot of clouds and all that, or LLMs are there, right? Just you might be knowing about ChatGPT, right? So when same thing, same question I asked a BE's computer science student today, are you aware of perplexity? She said no, right? Now people have moved from ChatGPT to Cloud AI, right? You can also search that. Cloud AI, the person who has written the Cloud AI architecture 3, 4 days back, in fact, last week, he has explained the architecture itself on his own. He said that he can run, and he has shown practical also. He said that he can run 5 agents at one time. Or in simple terms, you can imagine that you can run, or he can run 5 functions at one time. Basically, there's a basic different functions and agents, but he said that way. Now, means that is nothing but one person is handling the whole whole department, right? Instead of 6 people or 5 people, single person is doing the job of the 5 to 6 people on his own. So you can imagine that whatever disruptions are there. So if one person can do everything and all that, so in that case, you can imagine what about the software engineers. So this type of disruption is going to happen or going to occur. It is there in the advanced countries, means in the US and all that. Lot of disruptions are there. The wave may hit our engineers also, right, in the coming time and all that. So you should be ready for that. Being chemical, being a separate field and all that, but still in the chemical industry also, this agentic AI or this AI related, that AI can be used everywhere and all that. So that that they will have to learn all these things, right? Maybe in the next electives and all that, I'll suggest ma'am to add these AI based electives in their syllabus and all that. Maybe some additional subject or some additional, we can have a separate course also for that, so that they will be industry ready, right? So chemical engineer with knowledge of AI or the whatever uh, latest technologies are there, that way. Okay. So in 1970, 78 and all that, people talk about artificial intelligence, right? Then came machine learning and all that around 9, 10. Then after that, neural network, that we can say deep learning, neural networks and then deep learning. So now people go on just when you go for basically the chemical industry, right? You can take the case of oil and oil excavation and all that. So people are there when they were there in 1970s and all that. People talk about AI. Then they deep more. So when they uh, went inside, right, or they start digging inside and all that, they come across machine learning, then came neural networks, then deep learning, right, then generative AI. Now we are at the in the core, right, somewhere here, we are talking about agentic AI and all that, right? So 1970s to, you can imagine 2026 or as of now, and then a lot of disruptions are there in the AI field and all that, right? Then so then these are some of the types of AI models and all that, right? Machine learning model, as that day you might have heard about this from a lot of speakers and all that. Machine learning model, then deep learning models, right? Generative model, hybrid model, NLP models, computer vision model. So these are the different types of models or the different as algorithms by using which we can process or we can do analysis of any process, right? So it is up to you what process you want to use and all that. So basically now BHO 6 types of AI models are there. When you uh, reprocess it, right? When you again filter it, we may come across something like that generative AI. So this is how generative AI came into existence, right? You can generate any image, right? You can prepare any, because uh, now Mumbai University has introduced new subject, design thinking, right? So when you have to design any new product and all that, their generative AI can be used. People are not using, previously people used to use the paper and pen method to design or to define a prototype and all that. Now we have वो सब छोड़ दिया हमने, right? So we are left that now we are still that syllabus, in the syllabus same thing is mentioned. So that is maybe the gap with the industry and the academia and all that. But still, so now lot of other AI tools are there by using which we can do the designing. We can generate a website, right? We can define a user interface. So UI UX is dead, right? UI UX is dead. Basic programming is dead, right? Only thing is that is programming is what, if suppose you want to design a website for your say, let's say Prasida want to design a website for her, right? Previously she has to write a code, some CSS code and all that, HTML, DHTML and all that, right? Now by just giving a prompt to a basic AI tool, she can have her own website ready in hardly 10 minutes and all that, right? With other details. Then that website will be interactive. We'll ask about, should I add this? Should I add that also? Should I add this specification, all that? So that is possible now, right? Yesterday only I discussed, for example, you might be aware of, let's say, customer journey and all that, right? So people are, you might be very, in fact, we all are aware of that, right? Customer journey. So if you have to generate a customer journey map, so there you previously we used to prepare what are the customer requirements, right? What Then we'll have to do brainstorming, right? We'll have to ideate the things and all that. So first we have to collect the data, then you have to do ideation on that, then idea brainstorming and all that, right? So it's basically people used to have that edit method, that's empathy, then design, right? Then ideate. So ideate the thing. So ideation may you need members for that, committee members, team members, right? So then they will do brainstorming. ऐसे होना चाहिए, वैसे होना चाहिए. Output should be like this. The product should look like this and all that, right? Then you will go for prototype and then testing and all that. Now designing of everything, designing of any website, designing of any product, now that has become very easy now, right? That's why there are a lot of disruptions in the product design and all that, right? Best example of that is your Mahindra UX 7, that 700 and all that, right? So it has been observed that because my friend he goes there for that their model designing and all that. So there he came across that the Mahindra is using the basic all generative AI tools and all that. In fact, all might be using because this is common in Germany and all that, who are the uh, your automobile manufacturing units are there, right? So, but Mahindra is also using that, right? So this is how AI is used in day-to-day activities now, right? Now, 4 days back and all that, last is 1st of Jan, I plan to visit Udaipur and all that, right? So I use LLM to design. In fact, I have that other programs also using agentic AI. So you can design the itinerary for 3 days or 4 days. It is up to you, right? Where they will specify for that you will have to search some basic steps are there. But I just write the prompt that define the itinerary for 4-day visit to Udaipur, right? Where my budget is this much, and I want to stay near the means in the city because Udaipur is a, if you talk about Udaipur city, it is highly crowded and all that, right? Small roads and all that, right? Congested roads. So I specify that I want to stay, specify the hotels. Yeah, select the hotels which are near to that Pichola Lake. There's some lake over there. So I just refined my prompt and all that, right? Pichola Lake, my budget is this much, right? And uh, give me the detail, this thing, availability of the hotels, right? Like that. So the agentic AI tool or that agentic AI or LLM has defined everything in detail for me with all the specifications, right? Then he has uh, mention also that which flights are available on in which flights or in which this thing your flights tickets are available, right? You can whether I should go for Air India or Indigo and all that. So all these details are possible now. Now for that I will have to go to a planner, right? Previously we used to go to the क्या होता था, agents and all that, right? Then by ticket चाहिए ये चाहिए. Now everything is available. So that agentic AI can do it for me. It hardly took 5 minutes for the agentic AI to plan everything for me. So we have come from that age to now this age, right? So we are somewhere here. So we are talking of not generative AI or combination of generative AI and agentic AI. So this is a basic difference, right? The agentic AI has autonomy, right? Generative AI has creativity and all that. Then orientation is goal oriented because I have specified that I want to do or perform or I want this output, right? These are my requirements. So I refined everything and all that. So I got the proper output, desired output and all that and all. Decision making is independent because the heart of your agentic AI is a LLM. What type of LLM you want to use, right? Large language model. That day, sir also said that you can have a small language model also, SLM, right? So now people are doing research on that, SLM and all that. Each and every industry can have their own small language model. So because when you talk of large language model, we talk of billions of data to be uh, processed and all that and all. It takes more time. So basically, this is what is going on right now, right? So this is my user input. You can assume that this is my prompt, right? Then this prompt will go to the LLM. There's some large language model and all that, which is tuned with large amount of data, right? LLM, for example, you can have Chat GPT as a LLM, right? We can have Mistral AI as a LLM. We can have we can use Cloud AI as a LLM and all that and all that. We can use Perplexity as a LLM, and then with this LLM we can have a number of tools, right? For example, if I want to know what is the temperature there in Udaipur, right? Whether it is 9 degree or 10 degree, so I can get it. So that I can carry whether I should carry the warm clothes with me or not, That also you can come to know in advance and all that. For that Google, we can, for that we'll have to go to the Google and all that, right? But still that weather API is available. It is again integrated with Google API. So you can come to know everything on one page and all that, right? Then Web Explorer, right? For all combination. Web Explorer, basically one tool is there that is called as a DuckDuckGo tool. DuckDuckGo tool, by using that DuckDuckGo tool, I can scrap or I can crawl the whole of the web and all that, right? The search APIs are there, mass library, RAG API. So all these things are available, right? Only thing is that you have to write a proper prompt. मुझे आपको क्या चाहिए? It's the same as that of the that you have that talismanic lamp, right? So क्या हुक्म है मेरे आका? So that LLM or that agent AI will work on behalf of you, right? And the output will be available in hardly 5 minutes and all that, right? So what a desired output you want. If you don't have output, then give the iterations and all that, right? These are the observation, and then we can have a desired. जैसा आप लोग right? So I think better I should talk in terms of open loop system and a closed loop system, right? So when you talk of the closed loop system, because I taught process control long back in 1991 to 1995. So process control, after that also I taught, but for degree people, right? So that PID controller, right? Proportional action, integral action, the derivative action. So you all know about that. So basically, whatever output you get, if it is not a desired output, then what we'll do, we'll apply the part of that, means we'll apply the feedback signal, again feedback and feed forward. So we'll apply that input again to the LLM as shown over here, right? So we can refine it again, right? We can have the desired, unless we get a desired output, that iteration will continue. And then once we get a desired output, so now that will be done. You don't have to think about that, whether the output is desired or not. Agents are there. That agent will take care of that. I will see it later on, because let's say you want to do optimization of a chemical process, right? So you have defined 3 parameters. You want to optimize 3 parameters, right? Now the agent will take care of that. Let's say after 10 iterations, if you get the optimized output, then the agent will say that, yes, this is what is the desired or the desired output or the optimized output. Till then he will work on his own, right? So it is automatic in nature. Okay, so I think this is more than sufficient. So okay, so let me just discuss the what we are going to discuss today, right? Now you all know about that. So where are generally this is my method to put everything on the slide, so that if the person is not from this field and all that, so he will come to know what do you mean by new catalyst and all that and all. So you all being from the same field, I'll just simply touch to these points and then I will move ahead. So new catalyst discovery is what, right? Identifying, designing and optimizing materials or compounds, right? So that the chemical reaction can be done more efficiently, selectively and sustainably. So we will talk about the EAG also, right? So chemical manufacturing, everywhere this is used and all that. You all know about that. So in simple term, catalyst discovery finds materials that make chemical reaction faster, cheaper and greener. Because nowadays greening your output should be, because we have to take care of the carbon footprints and all that, right? Faster, cheaper pehle bhi tha, but this additional term green technology, that is now compulsory, right? So you have to take care of the carbon footprint generated and all that. Okay, so everything is going on for that only. So what are the steps involved over there? New catalyst discovery. These are the some of the steps. This enables autonomous closed loop catalyst discovery and all that, right? By coordinating multiple intelligent agents, means basically by coordinating LLMs, simulators, optimizers, and digital twins, right? So we'll use what we'll do. Today we'll discuss new catalyst discovery, how it can be done by using machine learning. Then we'll compare the outputs. Then what we'll do the same thing by using agentic AI, using LLMs and all that. Then we'll try to compare both, right? Then we can comment which one is better and all that, right? Also, I'll show you step by step. So next thing is, then what is digital twin and what is Pareto? So I think you are aware of that. So I'll show you mathematically that, because everything is math, right? So when you talk of any process optimization, in fact engineering, math is the integral part of engineering, right? So when you talk of machine learning, everywhere engineering mathematics is there, right? Because again, to be very frank and all that, I one and a half year back, so last year basically, I received a call from one of our students who has gone to USA, California. In fact, I received the same call from my daughter also, right? My younger daughter, she was doing MS there in USA, California. So I received a call from her. She asked me, Papa, machine learning, do you have mathematics? I said, Beta, engineering is nothing but mathematics is the integral part of engineering only. So she said that we are not learn that mathematical terms in our in Mumbai University syllabus, right? We come across only theory parts and all that. और यहाँ पे जो भी Chinese बंदा है, her professor, he from the day one he started with mathematics. He started giving the equations. He started proving that. Then he said, you can optimize it this way and all that, right? And that too, then again hypothesis testing, all statistics and all that was involved. That is the integral part of any algorithm, right? So we'll have to go to that level so that the things can be simple and the numbers never lies. So I'll try to show you that why that agentic AI is better than machine learning, deep learning and all that. So that we can come to know. So these are steps involved. So a lot of things in the next 1.5 year I'm going to discuss. So problem definition, objective setting and all that. So these are the things. Now ये objective ये होना चाहिए, constraints ये होना चाहिए. So you can go through this later on because I'll be sharing this PPT if required and all that, right? So basically temperature, pressure, cost, stability. So you all are aware of that, right? So we cannot have a temperature going beyond particular limit, right? Pressure should not be this much. Okay. So we know the example of that tragic incidence of that capsule, space capsule who was carrying who was that girl? Kalpana Chawla and all that, right? So when you're entering your atmosphere, right? So you have to take care of the temperature and the pressure of the capsule and all that. Cost and stability that comes later, but the life of a person is very important. So there, these things can be there, right? So same thing will be applied to any reaction and all that. Okay. Second thing can be knowledge, mining and data collection, right? You should know the knowledge of that, right? So you have to extract the catalyst composition, reaction conditions. तो ये सब आपके chemical terms है, right? Then catalyst candidate generation. So generator agent, as I told you just now, that generative है and this agentic है. So we can have different agents. तो एक agent होगा अपना generator agent. Agent is nothing but a small code, right? Who will do a specific task, right? So candidate generation. It will propose new catalyst, right? Composition ये होगा तो चलेगा. Then this, how much should be this much metal, ये support कितना, promoter कितना, ये सब composition वो he will define. Nanostructures or alloys. So uses large language model. So by using that generative model, domain heuristic, right? You can have a candidate generation or a generator agent. Then next we can have a next generator, that is simulation agent. So we may have a real data, but now as you have to design or you have to define anything or you have to do some innovation on all that. So first we'll have to simulate the things, right? So we can use digital twin for that, right? Or simulation evaluation. So for that we can have a simulation agent. So hope you all know about what is digital twin and all that. आजकल बहुत चला है digital twin होना चाहिए ना. I have published a lot of articles on this, right? So basically on LinkedIn. So I have published around 75 articles using agentic AI, right? So different types of case studies are there. In the digital twin is also there. You can, if you want, you can just refer that also. One is the article is using a case studies in agentic AI. Around 700 subscribers are there. So total 1000 or 1500 subscribers are there. Second is emerging technologies, right? So case studies on emerging technologies. So these two, I generally publish articles on these two. So I have prepared because this is a new topic given to me, right? So I have generated some new ideas and all that. In fact, at the end, I'll discuss the research topics, what people are doing in chemical industry using agentic AI and all that. So I have published some 3, 4, or I am in the process. Maybe by tomorrow, I'll just post it or upload it on the LinkedIn and all that. So I'll discuss that also if the time allows and all that. Right. So evaluate catalyst performance via physics-based model, ML surrogate models, right? So you know about the surrogation and all that. So prediction is the activity, selectivity, stability. तो ये सब possible है, right? So then we can have multi-objective optimization, means evaluation agent. So one we have generator, then simulation, and then the evaluation. So basically by using these three agents, we can have or we can achieve the right. So we can plan about generating a new catalyst by using the AI-based technologies and all that. then this evaluation agent kya kare? He will handle the trade-offs, right? Performance versus cost, activity versus stability, right? Then for that you can use the Pareto front analysis, right? Evolution optimization. So you all know about this Pareto and all that, right? So Pareto chart, Pareto analysis. In fact, because long back I used to teach project management also. I think for chemical, I think previously Prasida also used to teach project management all that. So there you might have come across Pareto and all that. Decision and planning, that is again the planner agent, right? So once you have done all these things, then evaluation हो गया, आपका optimization हो गया, then plan, right? Select the best catalyst candidate and all that. Means you have some options, right? From that you have to select a best one, right? So decide next experiment or simulation, at what level you should stop, adapt search strategy autonomously and all that. So all these things possible. So we can have a combination of these 3, 4 agents, right? And then lastly is memory and learning, because whatever output you got, we have to store it somewhere so that next time the we can avoid the repeating or the poor candidates and all that, right? So store outcomes of past trials, learn which category features work best and all that, and then avoid repeating poor candidates. This is very important. Again, different types of memories are there, right? With respect to agentic AI. So that is a separate topic, very vast and all that. But still, you uh, we'll have to store the whatever output you got, we'll have to store it somewhere, right? Otherwise, that is a problem with the LLM. The LLM, if you don't store, he will start from the scratch again, right? So first time, suppose you have done some optimization, all that, you have come across one particular product, a catalyst and all that. Second time, if you want to repeat the process, he will not take the desired of whatever output you got, the current output into consideration. He will start from the scratch again. That is the problem with the LLMs, right? So for that, we'll have to store the output in the particular memory location so that the repeating of the poor candidates can be avoided and all that, right? So that optimization can be faster. Otherwise, again, it will take the same time. These are the applications of this, right? People are using this or can be used for green and sustainable chemistry, right? CO2 capture and utilization, biomass conversion, plastic recycling. ये सब theory part हो गया, fertilizer and all that, right? Haber-Bosch optimization में where ammonia synthesis is done, so there also new categories can be discovered. We don't know what is there in the future and all that, right? Water purification also this can be used. So these are the some of the applications. Okay. So it is used in the chemical industry or can be used in the chemical industry, right? Now, why category discovery matters? Because central to chemical industry innovation. Nowadays, what is left as that AI, the guru of AI, right? The person who has written the best AI code and all that. He said that uh, AI, there is no innovation left now. We have to do the scaling. Sorry, scaling is not required now. Only thing is that we need some innovation, right? Because how much will scale? We have to be, you might have come across the LLM manufacturer, right? Or the LLM proposer. They says that my LLM can handle 2 billion parameters. Others says that my LLM can handle 8 billion parameters. Others says that my LLM can handle 64 billion parameters and all that. So this is more than sufficient. This much data is more than sufficient. Means that LLM is trained on that much, those many features, right? Or that much large amount of data. पूरा का पूरा encyclopedia, पूरा सब ये करके अपने all maths का formulas are stored in that maths का tool, right? So no formulas are left. So what is left now? There's a need for innovation in that, right? So scaling is not required now. Innovation is required in that respective field. So that's why people are now going for more innovation and all that. So traditional trial and error is slow and expensive. So that's why need for autonomous intelligence systems. That's why these new discoveries are available. So what is agentic AI that we have already discussed, right? So basically AI agents that plan, act, learn, and adapt and all that. So we have some code or we have some agents. You can imagine, you might be familiar with the C language functions and all that. Similarly, we have a complex function which you call as an agent who can autonomously on his own can plan the activity, he can act, right? He can read the feedback. So based on that, he will learn what is the problem. Then he will unlearn that, right? And then he will do some optimization. So, and then he will adapt, and then finally we can give the output. So multi-agents can work at one time, right? As I told you that Boris has explained that in one simulation he can handle 5 agents and all that. That is a very big thing, right? So it is there on the Twitter also. Or if I can share the link also, you can just go through that. So this is a very drastic this thing, or a big disruption in the technical field right now. So those who are aware of that, they got shocked how this Anthropy people or the cloud AI people can do this. People are struggling with handling or running only one agent at one time, and they were happy. Chalo chalo, I got the output. I am using agentic AI where I have written this agent, right, which can work in a sequential fashion. पहले मेरा ये agent रहेगा, फिर plan करेगा, फिर optimize करेगा, ऐसा. Now that guy is running 5 agents at one time. He has shown that he can run 5 agents at one time. It's 5 operations in parallel, right? That 2 agents who are self-learning, self-adaptable, and all that and all that. So people got shocked. Okay. So closed loop decision making. So all these things are possible. We have seen this right now. Okay. So from AI to agentic AI and chemical field or that, right? AI predicts outcomes and all that. Agent AI designs, experiments, learns and all that. Enables self-driving laboratories. So this is okay. Now this is the overall architecture as we have discussed step by step, right? So we have these agents, right? Now here, whatever operations we'll be doing. So by default, I have executed all this, whatever I want to discuss today. So if time allows, I will show you the step by step working, or I will execute it, or I will show the output, right? So basically we have 5 agents. One is generator, second is simulation, third is digital twin, fifth is evaluation, and the fifth one is a planner and memory, right? Now this will be run not parallelly because I'm using a basic laptop, right? That too without GPU and all that. But still, we cannot have these 5 running at the same time. If I am using a Google Colab and all that. For that, I will have to switch to cloud AI, right? So cloud AI, if I have now today only I downloaded, sorry, 2 days back only I downloaded that cloud AI and I tried to run 2 agents at one time. So I was successfully running 2 agents at one time by using a simple laptop, basic laptop, right? If there is a GPU in my laptop and all that, then I will be able to run more than 2 agents at one time and all that. So maybe after May and all that, that will be possible. So I can show you later on, right? That how these multiple agents can run at one time and all that. But I tried to run 2 agents at one time. That was possible, right? That was successful in that. I was successful in that. Okay. Now what else? Okay, yes, these are role of generative AI, right? Reduces search space, learns from historical data, proposes new catalyst composition and all that and all that. So now we don't have real data, right? So we have done some simulation. So for the simulation and all that, we need some simulation data, or we can generate the simulation data, right? So if you have real data, that also you can do, because as sir has also told that day that previously we were supposed to start PhD in chemical and all that, right? Now that it has been delayed because of some technical reasons and all that. So the student might have been, right? So they will be doing research on that using this agentic AI or AI and all that. Okay, so for that, but you need data for that, right? So then whatever data you have, either you should have real data or you can have simulation data, so that we can come to that if this type of data is given to the respective your application, so how it will react and all that, right? So some simulation results are there. For that, we can go for ML models, right? Digital twin integration is very important. Virtual chemical reactor, because we don't have reactor, right? So we'll have to design a reactor, right? Virtually and all that, right? Then some constant we'll have to put. Safer and scalable optimization is very important. Safety of that reactor is also very important, right? Otherwise, that Chernobyl type hazards may occur and all that. So closed loop learning workflow, it is like this, right? Design, simulate, evaluate, and then decide. That should be the workflow. So continuous improvement is required. So we'll talk about the closed loop system, not the open loop system, right? So no human intervention, it should work on its own and all that, right? So case studies, catalyst optimization can be another case study, right? So first we'll talk about the okay. So I'll show you how this can be done using some programming language and all that. Right. Now a lot of languages are there because when you have to simulate anything, so we'll have to for that we'll need the AI and all that. Right. So previously people used to use C language, right? C++. Then nowadays programming language, what is going on? So everywhere Python is going on. So by using that Python language, right? So we can design these type of simulation outputs and all that. So I'll show you that step by step. So what we'll do today, again that too, we'll try to be, or I'll try to be at the logical level. As I told you, that logically we should know what we are doing and all that. Oh, 119 people are there in the team. Let's hope that all are there with me, right? So first thing is, uh, this is my Google Colab. Now, what is Google Colab? I think you all are aware of that, right? So this is my Google Colab file. His name is autonomous. I given the same thing, autonomous catalyst discovery, right? So I'm using that IPyNB file over here. So first, what we'll do, we'll discuss about what is catalyst discovery using machine learning and all that. I should increase the font size. Editor. 60. Okay. Or okay. Right. Now hope it is visible, properly visible. Right. Prasida, it is visible properly?
Yes, sir.
Yeah, thank you. So first what we'll do, we'll try to run some code using agentic AI, using machine learning. So what I'll do, first we'll try to apply the machine learning principle over there to some simulated data, and we'll get some results, right? So we'll try to analyze the result. Then we'll use some LLM method or use some agentic AI term, agentic AI technology or agentic AI method, where again by using the same thing, same steps and all that, we'll get some output and then we'll compare which one is better and all that, right? So whatever output we have got, so which output is better and why this is better and all that, whether the new catalyst, what parameters should be considered and all that. So there are a number of parameters for designing or defining a good catalyst and all that. So assuming that you all know about that. So autonomous catalyst discovery using random forest regressor. Now this RFR, random forest regressor, this is nothing but a machine learning algorithm, right? It is basically ensemble technique. This ensemble, you know about a decision tree, right? So decision tree means suppose I want to go to the, whether I should go for voting or not, right? Whether means it should be either 0 or it should be 1. So output will be binary. Now that is my decision, right? Now suppose that there are some ensemble, the data is my ensemble. Ensemble means just 1 minute. Okay, ensemble is nothing but instead of one tree, let's say we have around 50 trees. We have 50 decision trees, right? Means for example, let's imagine that I have 10 members in my family. And so we'll take the output from each and every member, whether he should go, he wants to go and all that and all that. Everybody may have their own reasons, right? So output may be 0, output may be 1. So we'll combine all that and then we'll have a final output, right? Or you want, suppose you want to say, we have some option, morning में होता है ना जैसा mom पूछती है जो भी है या wife पूछती है जो भी है. So I'll take the example of the mom. So mom asks you that what you should have for morning breakfast and all that. So we can ask what options are available. So she will tell you these are the options available. You can have this, we can have this, right? We can have idli, you can have some other South Indian items or some we can have fruits like that. So each and every member have their own. So let's say there are 10 members. So if only one person is there, then he will give the output yes or no, right? This is available. Do you want this or not? So binary output. But if suppose it is a regressor, it is a forest, not a single tree. So that's why the name random forest. So the forest is random. There can be a number of trees over there, a number of decision trees. So each and every decision tree will give its own output. So we'll have to combine them. We'll have to ensemble them. Based on that, then we'll have to define the or give the final output. Just for example, अच्छा वो जैसा वोटिंग है कल, टुडे वोटिंग हैज बीन डन, राइट? नंबर ऑफ ऑप्शंस वर देयर, 4 from these people, 4 from this, so 4 parties are contesting, 4 for the 16, so we can have 16 people over there, right? There no their symbols and all that. So out of that 15, suppose you have to select 4, so number of combinations are there. So let's say 16 decision trees were there, and the final output we'll get tomorrow. This is what is the person who has won and all that. He is the winner. So binary में output आएगा. So same thing is my random forest regression. So basically linear regression, you all are aware, you might be knowing about linear regression. So here we are talking about the ensemble technique. So ensemble means number of inputs are more. From that we can have a final output. अभी ये सब आपके again I will not go into the details of that, this each and every code and all that. Generally I use that method to explain the each and every line of code. Now you being from the chemical side and all that, so I'll try to be at a logical level. So we need some Python libraries and all that. So we are importing that. For example, if you want to do some represent some data in the matrix form, right? So you have to use this numpy, then pandas, this and all that. If you want to process on that, this is the objective of that, pandas as PD, right? So wherever I want to use this pandas library, what I'll do, I'll write PD dot something. Same is over NP dot something. जैसे यहाँ पे मैंने लिखा है NP dot random seed, right? Then 42. So what is this random seed? Seed is nothing but it is a function where I'm generating some random data, right? So what should be, how many iterations, how many experiments I want 500 experiments. So here what I'll get 500 sets of data, right? Okay. Then for plotting the output, I will be using matplotlib. Then what are these algorithms are there? They are already stored in this sklearn. So now these are ensemble algorithms. So these are method from sklearn.ensemble import random forest regress. A method, right? Then training testing, because I have some set of data and all that. So in neural network or in any AI based technology, same type as we have to train. बचपन में हम लोग चलना सीखा है तो हमने, right? We didn't start working on the first day and all that, right? Because we are from the human being family and all that. So we take around 9 months and all that, जो भी है 6 months to or some particular period. So or we learn the things in steps, right? So first step, second step, like that. So we don't start running. So same thing over here. We have to train the neural network. So training is very important, right? आपको अगर गाड़ी सीखना है तो you'll have to do the minimum 21 days का course and all that, right? That 21 plays the important role. So they said that if you want to train your brain for some particular action, so we should repeat it minimum 21 times, right? So same thing over here. That is my train test split. So I have to train my neural network. I have to train it. Once it is trained, then I can test my data on that, right? Then only I'll get the desired free output, or the whatever output I'll get, that will have minimum error, right? जैसा हम लोग उसको in machine learning or in deep learning term, we say that less errors will be there and all that, right? Okay, or hallucination will be less. Okay, then what parameters or metrics I want to print? So I can go for any error, right? So here I'm using the mean square RMSE and all that, so that we can come to know which one is better and all that. हम लोग RMSE compare करें, right? So other parameters also there. We will plot the output and all that. So second thing is in this cell, these are the different cells, right? So my experiments are 500. This is my description of the catalyst, right? Now you all are aware of these parameters and all that. So you better know about this, right? So metal ratio plays important role. So number of features are very important when you have to design or when you have to define a new catalyst. So out of that, 3-4 parameters or features I am using over here. So one is the metal ratio. Then second is support active acidity. Third is surface area, and the fourth is the reaction temperature, right? So assuming that these are the 4 important features, so I'll concentrate on this because feature simulation also plays an important role. So that is again a basic things of feature extraction. Whatever important features are there, we only extract that, right? And the remaining less important features are generally neglected, so that the time required for simulation on that can be minimum. That is generally the process followed. Just if you want to just compare this with the candidate selection in say your BMC and all that, what these parties are done? The parties are selected the best candidate, right? What was the criteria, right? What is his winning criteria? उसका winning percentage कितना है, right? How much control he has, or how much he is, क्या बोलते हैं उसको? Whether he is the person of the layman, right? लोगों का दोस्त है नहीं है, something like that. So all these things are considered. So we are going for these four parameters, right? So metal ratio, support acidity, sorry, surface area and the reaction temperature. Then simulation performance, we'll have to define the yield percentage and all that. Now here you can, this is the standard equation which is used. So 60 into metal ratio plus 0.01 into surface area. So 0.5 into support acidity, 0.02 into reaction temperature plus the random normal and all that. So here we have four variables. So my this loop will go from 0 to 3 and all that and all that. And what is my n? N I have gone for n is equal to 500. Right. So whatever options are there. So what I'm doing, what I'm asking my random forest algorithm that this is what is the, these are the different descriptors and this is what is my, I want the output. My simulated performance function should be like this. My yield percentage should be this much, right? With the involvement, yeah, the percentage of these four parameters is like this. So 60 into this, right? 60 ये ले लो, जैसे आपको suppose you want to prepare क्या अभी कुछ मान लो you want to prepare say any preparation, right? So we are preparing a new product over here, right? Or new catalyst and all that. आपको कुछ नया बनाना है, so we'll have to, let's say, any new product or any new your dish and all that. So there you have to define, right? अभी होता है ना, मॉम ने बोला है इतना ही हल्दी डालना है, इतना ही मिर्ची डालना है, right? 10 gram of this, 20 gram of that, okay, like that. Then selectivity. So one is yield percentage, second is selectivity. Selectivity plays an important role again, right? What selectivity parameters should be there? That also you have defined. Okay. So metal ratio, surface area, support acidity. Only three parameters are there. That's why my loop is going from 0 to 2. And this will be repeated 500 times. Okay. Then we'll prepare a frame of that. What data I'll get, simulated data, I'll put it in the frame form, right? Because for processing or finding the matrix and other matrix and all that, we'll need the data in the form of data frame. But that is the Python method to prepare that data into or put that simulated data into frame, right? Some columns and rows will be there. That is called as a data frame. So that the processing can be done smoothly and all that. So what I'll have, we'll have 1, 2, 3, 4, 5, 6. So 6 headings will be there, 6 features will be there. Metal ratio, support acidity, surface area, temperature, yield and selectivity. Okay. Then I can print it. So if I execute this code, I'll not be my online execute nahi karunga. I already executed this. So I can share the output over here. So now I want to print only the first 5, right? If I specify, if I want to print all the combinations possible, so my data set will have not 5 entries, I will have 500 entries because my n is equal to 500. So I don't want that. I just want to know what is the nature of my matrix. So I can imagine how much memory is required for storing this matrix, right? So I'm getting some simulated data over here, right? For example, in the 0th operation, 0 to 4, data.head will print the first 5, right? So 0 to 4, those parameters are listed over here. My temperature is this much, right? So in the 4th iteration, 490.09 like that. Okay. So these are my different data are there. So what I'll do now, I'll put that data. Now I'll use this data for training and testing. So कितना data है मेरे पास? 500 sets of data sets are there, right? वो डेटा में क्या क्या है? डेटा में ये आपके 6 पैरामीटर्स है. एक मेटल रेशियो, सपोर्ट एसिडिटी, सरफेस एरिया, टेम्परेचर, yield and selectivity. So these 5 parameters are there, 6 parameters are there. How many sets? 500 sets of data, 500 sets of these 6 parameters, right? So 500 into 6, that much data is available. Now what I will do, I will have to train that my machine learning algorithm. Now on what parameters I'll train? I'll train it on metal ratio, support acidity, surface area and temperature, right? What I want the yield. So that's why this is the method x train, x test. तो मेरा x जो भी variable है उसको मैं train करूँगा, right? और test करूँगा. So training, testing, there's some. Now see here, if you look at this, so this function, train, test, split function has 2 parameters, basically 3 parameters, x, y, and test size. My x is my input, y is output, right? And my test size is equal to 0.2. What is the meaning of this? The meaning of this is very simple, that my testing size will be only 20% of the data. Means what? Whatever 100% data I have, 500 जो भी data sets है, उसमें से 80% data I'll be using for training. Remaining 20% I'll be used for testing and all that. So that my algorithm will give me the desired output or the output which is having less amount of error, right? So very small amount of error will be there in the output. Error will be there, right? We cannot have 100% efficiency over here. So what type of model I want to use? So I have specified that model is random forest regression, right? How many estimators are there? So I'm assuming that there are 200 trees and all that, right? So model dot fit किसके ऊपर fit करूंगा? X train के ऊपर my input and then what is my Y train. So X train, Y train इसके ऊपर I'll fit the model. So I'll apply that model on these two variables, right? Where 80% of the data is used for training and the 20% is used for testing. So it will select randomly, right? And what my model will predict? So it is up to me what metrics I want to display and all that. So I want to measure the MSE or RMSE, right? So you are aware of that MSE, RMSE, right? So what I'll do, I'll print the RMSE and all that. Now you all know. So after executing this code and all that, I got this RMS equal to 3.9619 and all that, right? So for this random forest regression algorithm. Now we know what is RMSE, right? Whether it should be minimum, it should be maximum. What's the formula for RMSE and all that? It is a root mean square of something, right? It is a root mean square of a mean square error and then root of that. So we take the error, right? We'll find the mean of that. Then we'll square it, right? Because sometimes we may have negative numbers also. So what we'll do, we don't want that negative number. So we will make the square of that and then we'll take the root of that so that we can have positive output. So RMSE should be larger or it should be small for a good algorithm that you all know about it, right? Then my agents. So I got RMSE equal to this much. So मेरा training हो गया, testing हो गया, मुझे error इतना कुछ मिल रहा है. Now I'll go to the agents, right? So what are my agents? As I told you, generator agent. So this is my generator agent, right? What it will do, it will go for the data frames. It will take the data from the data sets, right? And how many iterations I want, what should be the temperature variable should be how much and all that. So these four parameters are used by the generator agent. Or generator agent will design or define the condition where all these four parameters are there. Then we'll have to evaluate. So next function is my evaluation. Define evaluation agent on the candidates. How many candidates are there? We have defined 200 candidates, right? So predicted here, model will predict candidates and all that. It will return the candidate type and all that. Then whatever output you got, because आपको iteration मिलेगा ना, so we'll have a number of iterations. So what we'll do, we'll have to use some array, right? Where we'll store that data or that क्या बोलते हैं उसको आप output of the first stage and all that, first iteration. So for that we are using this array. History is equal to array this for iteration in range 10. So 0 to 11, right? Or means 11 iterations के लिए. So candidate generator agent, then evaluator agent, then best evaluation is how much is the output and all that. And then we append it to the history. So at one time we can have 50 agents, right? Or 50 sets of data process. It will be stored and all that and all that. So it is showing me output. So if I run this code and all that, so I will have, because I'm running for the first 10 iterations, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got that best predicted yield is 65.15. If you want, you can, because see what we are printing the best predicted yield. किसके लिए आपको best combination मिलता है, right? So print only the first 10, right? Or go for 10 iterations. That is what is number. If I increase this, right? If I increase this number, it will show you more iterations. But if you go for more iterations and all that, the system may become oscillatory, right? It may need more time. So for simulation, we are going for 10 iterations. 10 iterations is more than sufficient. If you want to refine it, go for more iterations, right? So it will take some time, more time, but the error may be reduced and all that. So you might have seen it in some previous speakers might have explained that, right? So, and then if I want to, after this 10 iterations, right? If I want to plot this iteration and the best predicted yield, so I'll get output like this. See what I'm doing? I am plotting this here. right? If you want to plot this, iteration and the base predicted yield, right? So, and this is my title, agentic AI autonomous catalyst optimization, or we can give this simple autonomous catalyst optimization. So I got the output like this. So what is important? Analysis of this output is important. What is there on the x-axis? X-axis we have iteration, y-axis we have base yield. This one. So this is my output, right? Iteration will versus base predicted yield. Now what analysis we get from this? Anybody from the audience? Okay, so audience का mic is enabled or disabled? ठीक है,
Unable,
चलो.
unable
Okay.
है sir.
Yeah, sir, थोड़ा anybody can just tell me how what is the output, whether it is good or it needs more iteration or it needs, because you all are aware of this, right? Best predicted yield and iteration. So here we are going for, okay, I'll only ask the question. I will only try to give the answer, right? Because it is online this thing. So most of the time we generally hesitate, right? कैसे पूछे, क्या पूछे, कैसे बात करें. So we'll try to give more stress on understanding part rather than discussion. And then running the programs and all that, if I go for this, so I'll be able to explain only one set of code and all that, right? So that's why I'm using this. So I'm saving my time. So मैंने पहले से compile करके रखा है so that this is the output and then we can compare the output and all. Okay, so I'll be using this method because if I go on explaining the program line by line and all that and executing that online, so it will take more time. So we will give more time for discussion. In fact, if you want, I will share this code. You can run on your own and then you can see the output. ठीक है, ये जो भी है आपके सामने है. Now if you analyze this, right? If nowadays it is now very this thing. क्या बोलते हैं? LLMs are there. What if suppose you get some output and all that, right? I will show you. If you don't get the meaning of this, right? If you're not getting what output I got, why you got this and all that, right? So I'll tell you one simple method. Right. So what I've done, see, we should be able to use the technology, right? So what I've done, I got this output, right? Now I don't know why this output is like this, right? What is the meaning of this output and all that? मैंने क्या किया, मेरे मोबाइल में परप्लेक्सिटी ऐप है. So I open that app. Right, जैसा आपका चैट जीपीटी होता है, you can use chat GPT also. But I believe I trust more in perplexity, right? अपने बंदे का है, राव का है, राव का. So as we MB Rao also, similarly, this is designed by our own ABCD, right? जो अमेरिका में है वो, अमेरिकन बॉर्न जो भी है वो, तो राव ने बनाया, इसलिए आई एम more emotionally attached to this perplexity. So what I done, I taken the image of this and I gave it to the perplexity. भाई ये analyze करो, मुझे output बताओ. You can do this on your own, right? आप भी कर सकते हो. You can give it to chat GPT, you can give it to Gemini, you can any LLM, right? So I given it to chat the perplexity, and he has given that what the curve best indicates. The y-axis is best predicted yield, so each point represents the highest yield found up to that iteration or all that. Yield increases quickly in the first two iterations. देखो पहले दो iteration में 0 to 2. See what is the output, and then just have a look at the code. I'll just read it for you. Yield increases quickly in the first two iteration, then mostly declines. बाद में कम हो रहा देखो 2 to 4 में it declines, right? Declines or plateaus, suggesting the search moved away from the initially permission region and all. So why there's a decline? ये देखो 0 to 2, 0 1 में वो कम हो गया, फिर 2 में reach the maximum height, right? So yield is high. After that it dropped from 2 to 4. means 68 से directly around 50 पे आ गया in the fourth iteration. Why this is there? हो सकता है वो आपका जो ट्रेनिंग है या टेस्टिंग है, वो आपका ट्रेन जैसा वो ट्रैक से निकल गया, खेत में चला गया, समथिंग लाइक दैट. हाँ, वो ऐसा कुछ आता है ना, दैट वन पर्सन केम, सो द ड्राइवर सेड आई वेंट ऑन द फील्ड. So this may be the same thing over here. In the first two iteration, then mostly declines or plateaus, suggesting the search moved away from the initial promising region and all that. Then again in the fifth iteration, it rise. Six में वापस कम हो गया. But when you go for more iterations, as I told you, we are going for 10 iterations. So after that, the yield remains almost constant, around 65, right? After 8 iteration or another. So this pattern resembles an algorithm that is over-exploring the test diverse conditions, but doesn't reliably exploit the high yield region once discovered and all that. है ना, एक बार बंदे ने 68 मिला लिया, उसके बाद में रन रेट उसका कम हो गया, right? So he is not with diverse conditions को adapt करने के लिए is not suitable, right? So he is not reliably exploit the high yield region once discovered and all that. So the absence of a clear upward trend or asymptotic convergence implies that either the surrogate model acquisition function is poorly tuned or the search space is noisy and the agent is not incorporating certainty or replication. Right. So this is what is the output. तो मैंने तो एनालाइज किया नहीं, मैं तो ये आपको यही बताने वाला था सिंपल कि देखो इन द फर्स्ट इनिशियली द यील्ड वाज 66 or 67, right? Then in iteration number 1 it dropped down to 62. Then in iteration number 2 it got the maximum output, right? Then again in iteration number 3 to 2 to 4 it started decreasing. So 58 PO it reached the you can assume that that is the end, right? So lowest value. Then again from there in iteration 5 it started. Means this output, this algorithm output is not reliable, or it is not remembering the previous set of iterations and all that, right? So we cannot, this the reliability of this is not that good, right? So exploitation after finding a high yield region, it should stick to that, right? Once you got the high yield parameter, it should stick to that. Nearly it should remain, means 2 से लेके this curve should be flat, है ना? यहाँ पे ये flat होना चाहिए था, ऐसे ऐसे flat होना चाहिए. At the moment are increasing, but ऐसे नहीं हो रहा है. That is the problem with this. This problem is there with the algorithm. Hope you got this, right? So now if you plot this, किसमें issue है, metal ratio कैसे है, metal yield कैसे है with respect to metal ratio and all that. So we can plot these different 4 parameters, जो भी 3 parameters है. So these are output. I'll display it here. Metal ratio with respect to yield. These in the increasing order, right? But lot of these problems are there. So metal ratio and yield, there this with respect to metal ratio, the yield follows the increasing pattern, right? But what about, so where is the error? Where is the problem? The problem may be with the another parameter. Now if you go for surface area mein there is some issue. If you look at the surface area, see here, this is the surface area impact on catalyst performance. Surface area 500 तक आप increase कर रहे हो, so my yield is somewhere it is minimum, in some surface area it is maximum. यहाँ पे देखो ये इस area में यहाँ तक जगह है 50-60 तक, right? Then when you go for this much surface area, then it has reached around 65-68 only. So there is some issue with the surface area, right? Or tuning with the tuning of surface area. So that's why the yield is not proper and all. Getting? Now what we can do, we'll apply this with respect to your machine learning method. तो मुझे output की मिला, output में my RMSE value some, and then my yield is my output error, right? So that yielding is not proper, it is not constant, right? It is oscillatory in nature. Initially it reached a maximum of 68, then it dropped down and all that and all that. So that is not a good algorithm, right? Or not good design and all that. So we'll go for, so we'll try to add that agentic term to this, right? Now agentic mein, when you talk of agentic AI, I hope this is clear, right? What we have done, summary of what we have done till now. So I started with what is agentic AI. What do you mean by now case study? So I'm going for first case study. Case study is new catalyst, right? Innovation or innovating new catalyst. So there, what I did, I have some sample data. I have decided the parameters on which I want to, or features, on which features I want to apply, or I want to design the new catalyst and all that. So that we have mentioned. After that, we have decided their percentage and all that. Then which algorithm we are using? I am using a machine learning algorithm. Number of machine learning algorithms are there. उसमें से मैंने I selected the my forest, your random forest regressor and all that. This random forest regressor is a ensemble algorithm where it can have multiple outputs, right? जैसा आपने देखा ना 500 samples are there. So each and every sample will have its own output and all that. So this 500 sample will have, I will have 500 sets of data. So on this 500 sets of data, I applied my algorithm. तो वो जो भी 500 sets of data है, उसमें से 80% of the data I use for training, 20% I use for testing and all that, right? So that my algorithm, my machine learning algorithm can be properly trained. Basically, it is a neural network algorithm, right? So इतना ट्रेनिंग करने के बाद 80% डेटा के ऊपर ट्रेन करने के बाद वो बंदे ने मुझे आरएमएस को 3.5 कर दिया. एंड देन when I plot the matrix yield, so in that case I come to know that in the first 2 iterations I am going for 10 iterations. So in the first 2 iterations I got a very high yield and all that. After that the yield reduced, right? It reached the minimum bottom region 58 54 कुछ गया. उसके बाद में थोड़ा जैसा मार्केट में होता है वैसे, राइट? शेयर पहले सुबह सुबह जैसे ओपन हुआ मार्केट, इट इज अ मैक्सिमम वैल्यू. देन फिर मींस पहले 1 घंटे में 9 बजे खुला, मान लो मार्केट आपका ओपन हो गया 9:30 9 o'clock. So till 10 o'clock it was at high, right? Then between 10 to 12, at 12 it plunged down to some minimum value. Then थोड़ा सा मार्केट सुधरा. After that, after 8 iterations, या 8 घंटे के बाद, at the time of closing and all that, the share value remained constant around at 65 62 जो भी है. I'm not satisfied with the output, right? I'm not satisfied with the yield and all that. So what I'll do, instead of going for machine learning, I will go for agentic AI. You can go for deep learning also, right? वो बहुत ज़्यादा हो जाएगा because it is not possible to cover me that in 2 hours. Generally, whenever I go for any FDP and all that, right? So I take minimum. I took generally I request this thing that you give me minimum 2 sessions so that I can explain the things in much detail and all. Otherwise, it will be simply क्या बोलते हैं उसको, working on the application layer, yeah, or running with the speed of I am going at a high speed and all that, right? Jet speed. So I don't want to do that. Next week again one more FDP is there. I asked the coordinator that I want minimum 2 sessions. If you want me to explain agentic AI. So what is agentic? Most of the people they don't know what is agentic AI and all that. In fact, the IT people they also don't know. So or the CS people, right? I mean, those who are there from this field, they are not aware of that up to that detail. If you ask anyone, for example, LLM, so what goes inside the LLM? अभी जैसा हमने LLM use किया है या हम लोग use कर रहे हैं. If you look at this, you will come to know that what LLM I am going to use. I am going to use this LLM, Mistral AI, right? With that I am using LangChain. So Mistral AI LangChain I will be using this, right? So this Mistral AI is a LLM, right? Designed by French people and all that, right? अभी इसमें advantage है, I can use OpenAI LLM also, right? I can use Grok AI LLM also, Elon Musk का. कल ही शायद न्यूज आ गया that most of the countries they are putting ban on this Grok LLM, right? In fact, US is now integrating this Gemini and Grok into their weapon designing and all that, right? People are using this for designing lethal weapons, how to increase the speed of that and all that. That is, so उसके ऊपर research चल रहा है. So this Mistral AI is it has its own open LLM and all that. So you don't have to pay for that key and all that. That's why I'm using this. If you want, you can use OpenAI also. Right. So we are using this LLM. Now if I execute this code, it will show me this is this. इसको time लगता है. So that I already run. So I'm showing the output. Right. All requirements are satisfied. This, that, and all that. So finally, my LLM. I brought the copy of the LLM over here. I imported that LLM. Right. So what I'm importing this. 3-4 parameters I'm importing. I'm installing this LangChain community, Mistral AI. Yes, now you know about these pandas, NumPy, scikit-learn and all that. Okay. In सब को मैंने install so that I can use them in my program. So when I move ahead, again I will need the data and all that. So this will remain same, right? This remains same. Import NumPy as NP, pandas as PD. If I want to plot that, I'll use this. So ये सब same है. From this import this. So I am using random forest regressor. I am using importing chat Mistral AI also. Now this is my Mistral API key. OS.environment Mistral API key. This is my API key, right? So this API you can have your own API key, free है, right? और फिर LLM. So कौन सा LLM है मेरा? Mistral AI LLM. So I'm using that. So what I'm doing here, right? LLM is equal to chat Mistral AI, name of that LLM. Model is equal to, now the different models are available of this Mistral AI, small model, large model, and all that. So I'm using a Mistral large data set or the large latest, right? Temperature equal to 0.7. Now this temperature parameter plays an important role. Sometimes if you can set the temperature equal to 0.2, you can set the temperature equal to 0.5, you can set the temperature equal to 0.7, so that the operations can be smooth and all that. Less number of oscillations can be there. Now this is what is my catalyst knowledge schema. Catalyst descriptor, metal ratio, which you already done, surface area, reaction temperature. Okay, so we'll be considering on these 5-6 parameters. My schema is like this. Second thing is I will have to generate the data. How many samples and all that? I'm using the same method, right? So random, same logic. Okay. So np.random seed. Either you can write 40 over here, or you can write 42, or you can write 0 also. And it is equal to 600. Now पहले इसमें मैंने 500 लिए थे sample. I am going for 600. Which parameter? These are my 4 features. Metal ratio. The same. This everything is same, right? 60, 70 जो आपको देना आप दे सकते हो. It is up to you. ठीक है? Ratio this much. Then what we'll do? We'll prepare a data frame of that. जैसा last time अपन ने किया था, right? So still here it is same. ठीक है? How many lines of data will have? How many rows I will have? 1, 2, 3, 4, 5. Here I am not using going for selectivity. So 5 columns, and then how many rows are there? If I go down, 600 rows are there. Okay, चलो, वही 725 हो गया. Then again training, testing and all that, right? Again test size equal to 0.2. It is same thing. Now if I plot this, initially what we'll do, I'll use the random forest regression algorithm. So I'm getting RMS equal to 3.39. So I'm not satisfied with this. So what I'll do now, I will give the output to the LLM. So it's a combination of both, right? So now I'm using this. Now Mistral, I have mentioned this, right? Mistral power generator agent, LLM reasoning and all that. Now this is very important. Now I have LLM, imported my LLM, right? Or I installed the LLM. Now I want to give my or generate my prompt. तो पहले इसमें क्या था, prompt template में हम ये prompt में हमने दिया था prompt planner that this is what is I required. Now here I'll write the proper prompt. I'll write the proper prompt in the generator agent. Now my generator is not simple generator, it is a powered generator. Which powered? Mistral power generator. What is Mistral? Mistral is an LLM, right? So I'm going for LLM reasoning now. तो मैं क्या बोलूंगा, देखो मेरा ये रिक्वायरमेंट इज वेरी सिंपल. इनपुट वेरिएबल हिस्ट्री में स्टोर करना है, हिस्ट्री इज एन अरे, एंड माय टेम्पलेट इज दिस. व्हाट आई राइट ओवर हियर, दिस, ओके, आई वांट दिस इज माय टेम्पलेट, राइट? यू आर अ केमिकल कैटालिस्ट डिजाइन एक्सपर्ट. ठीक है, हमने उसको बता दिया भाई तुम एक केमिकल कैटालिस्ट डिजाइन एक्सपर्ट हो. आपको एलएलएम को बताना है ना कि तुमको करना क्या है. You'll have to, he is there, standing there in front of you. क्या हुक्म है मेरा, क्या हुक्म है मेरे आका, बोलो क्या करना है. तो आपको बताना पड़ेगा उसको कि भाई ये करना है. Then only he will work for you. So you have to make the AI work for you, right? So you should be a good prompt generator or prompt writer, right? So based on previous best catalyst yields and all that, right? History पढ़ो, history पढ़ के आप मुझे new catalyst define कर दो, design करके दो, where my metal ratio should be in this range. I'll have to specify the range also. Metal ratio in this range 0 to 1. My support acidity should be 0 to 10. Surface area 50 to 500, and temperature is around 300 to 800. Now this you'll have to write, right? You'll have to define. आपको temperature कम करना है, आपके हाथ में. आपको metal ratio कम करना है, it is up to you. Means what are your requirement, that you'll have to tell him, भाई I want ये और मुझे बना के दो, right? जैसा अभी AI based cooker has come, right? Right, so we'll have to specify that this is the input, I want this, so prepare a dish for me. So he will prepare a good dish for you, that AI will prepare a dish on behalf of, say, your wife or your mother, jo bhi hai. It will be better than if the training is proper and all that, we may have a new dish available. Okay, so return only numbers in this format, metal ratio, मुझे आउटपुट में ये चाहिए, बस ज्यादा कुछ नहीं, right? And it is a chain, so generator chain is equal to prompt LLM, right? Using this cell to chain prompt and LLM means ये सब parameters है, इस basis पे आप you generate the chain and all that. After that we'll have to, so my generator is now LLM based, right? आपने input उसको दे दिए, ये range में मुझे output चाहिए भाई, right? So proposed output should be this range. It is up to you now, right? तो मुझे नमक कितना चाहिए, शक्कर में, चाय में शक्कर चीनी कम चाहिए, right? या कड़क मीठी चाहिए, it is up to you. So that LLM will prepare a tea for you or coffee for you and all that, right? This much capacity should be there, this, that and all that. It can be anything, right? Then evaluation agent. I want prediction. किसके ऊपर चाहिए, right? So see prediction what data frame के ऊपर and all that. Then planner agent. Planner agent क्या करेगा, वो आप उसको एक तो history input आएगा, history hills and all that. Again it will be a closed loop, right? That's why this is specified over here. Sorry. Here. Planner agent, closed loop autonomous discovery and all that. So now again, I have to be at a logical level, right? Assume that you all know about this. There's someone who is writing this code for you and all that. You don't need to write this code and all that, right? I'll share this PPT, I'll share this IPNB file. You can simply run this. और देखो ये output आता है. But this is one of the code, right? Where I have given the specification all that. I want output like this and all that. तो मुझे predicted value दो, best value, best yield मुझे चाहिए, history yield, साफ सब जो भी हिस्ट्री है वो देखो, so that error can be refined, right? Accuracy should be more. So I'll print the iteration, I'll print the candidate, right? So once I execute this code, I'll get output like this. And predicted yield. How many iterations I have specified? I have specified these many iterations. What I got? I got output of this type. I will place this output so that we can see it properly. आउटपुट स्क्रीन नहीं लिया मैंने, सॉरी. Control Z. 1 minute. Autonomous catalyst agent. Okay. I'll show you the output here only, right? So iteration number 1, iteration number 2. Right. So just have a look at this. The numbers may be थोड़ा small. मैं iteration वो दिखता नहीं है, screen में नहीं बैठेगा. Iteration number 1, I got candidate 0.35, then 6.2, 320.0 and 550.0. What are these 4 parameters? First was my metal. ये जो मैंने 4 जो specify किए थे ना, वो है first iteration में. क्या है iteration में? What are the 4 parameters? Metal ratio, right? Support acidity, surface area and temperature. So in the first iteration, I got output like this. The iteration number 1, metal ratio is this much, second parameter, third parameter this, जिसका range मेरा 0 to 500 था, second was 300 to 800 जो भी है, and the yield is around 29.21. It is in percentage, so 29% yield is, it is this thing very small. So second iteration, right, my parameter change 0.35 to 0.45, then fourth iteration, fifth iteration, three iteration continued. And finally, I got at the 10th iteration number 10, iteration number 8, I got this final out. 0.65, 4.2, metal range is in the range of 0.65, right? Then second parameter is second parameter is 4.2, right? Second parameter, third parameter is 380 and then 5. So for that, I got this 49.54 and all that. So it is up to me how many output or how many iterations I want. So I'm going for less iterations. So if you want, if you have time and all that, we can go for more iterations. So this is how simulation can be done. So I can get the output like this. Means for this combination, I can have yield, predict yield to be this much and all. Now, if you plot this, you'll get output like this. Now, just have a look at the output. I'll increase the this thing, right? Now, just have a look at this output, or I will display it on the new tab. This is my output. Okay, iteration. I'm going for 7, 8 iterations only. If you want, now go for more iterations, right? But I think you got it. I'll just compare it later on. Next PPT में मैं compare भी करके आपको बताऊंगा. This is the best predicted yield, right? Initially, it was around 25, 29. Then it jumped to 40. Iteration number 1, very good jump, right? फिर बाद में 2 पे थोड़ा third iteration पे वो flat हो गया. I am not using digital twin now, right? Then it jumped to again 45, 48, 49. Then iteration number 5 पे थोड़ा कम हो गया. Then again it's tuned properly and it has achieved a height of around or a yield of 49% around. Means the output is stable. If I go for more iterations, I may have jump over here. It may increase or it may remain stable. It may give standard output. Now, if I'm not satisfied with the yield and all that, I'll have to change my input parameters, right? So you can refine the output. So it is up to you. Means if I change the iteration from this to this, right? Then I may output like that, or I will have to go for more iterations. So that is possible. But in that case, we'll have to, my system will become more oscillatory. अगर आप more number of input दोगे तो बहुत वो जैसा वो कुछ किसी का डाला हुआ है ना वो नसरुद्दीन शाह है कौन सा है some actor का some joke is there अपुन को लगता है अपुन इस खुदा है वैसा तो आप अगर वो एलएलएम को और बहुत ज्यादा डेटा सेट पे आप ट्रेन करोगे तो उसको लगेगा भाई अपुन ही है और कोई नहीं है राइट समथिंग लाइक दैट जैसा अभी इफ यू लुक एट द just compare with the standard scenario and all that, right? If you come to know that BJP is acting something like that, भाई इधर अपन नीचे एक पार्टी है, right? There is no opposition. Opposition वाले डर गए, फिर वो शुरू हो गया. आपके अस्मिता की लड़ाई ये वो and all that. So people are emotionally blackmailing and all that. जो भी है, right? Yield distribution, if you plot, now it is again up to you how many matrices you want to plot and all that. So I'm plotting yield with respect to frequency. Frequency also plays an important role. See here, if I go for yield and frequency, then you come to know that if I want to go for 80, so mera somewhere around here, 40%, 49% yield pay, I'm for this, I'm my frequency of this is this much. So it is up to you how many parameters you want to print and all that. Metal ratio versus yield भी अगर आपको print करना है, so this is a metal ratio versus yield. It is in the increasing order. Metal ratio plays an important role again. Then if you want other things and all that. Now our problem is, let me go there. Right. Comparison किधर है? Okay. So I got this output from the first case, right? And the second one, where I am using Mistral LLM and all that. So this is the agentic AI based output, right? And this is my normal output. I got output like this, right? But here it increases some of that. Okay? At the iteration number 7, it reached 50 or 59 and all that. But in the first case, it reached a maximum of 68. उसके बाद में वो बंदा 64 पे आ गया, right? Lot of iterations are there. Sorry, oscillations are there and all that. So it is, you have to decide which method you want to use and all that. If you compare the effect of metal ratio on catalyst yield and all that, then again both the trends you will come to know that these are increasing, but here the metal ratio, the yield is more when you go for metal ratio equal to 1, because metal ratio अगर आप 1 पे जाओगे तो yield is around 80%. Right, this output, this second one, this output for the second program. So again, if you want, अगर आप surface area impact अगर consider करोगे तो for 500 surface area, the yield is above 600 and all, 60% and all. So it is up to you, right? So by using different methods, you can do this, right? Similarly, you can go for digital twin also. You know what is digital twin and all that. So I tried with the digital twin, right? Digital twin में क्या किया? It is a combination of integration of Mistral AI, LangChain plus ML plus Plosys digital twin. So what is digital twin? Digital twin is nothing but a physics which inspired virtual reactor, right? It's similar to reactor behavior, incorporates process out conditions, right? You might be knowing about this digital twin and all that. Add consent not seen in ML data, improves trust and scale up relevance and all that. Digital twin output is generally conversion, energy penalty, catalyst deactivation risk, and the final adjusted yield. Right? Conversion आपको plot करना है. You have to consider the parameter energy penalty. Energy में कुछ penalty लग रहा है क्या? Then if you want, sorry. Okay. Catalyst deactivation risk कितना है? And what is the final adjusted yield and all that. So hope you all know about this. So I'm using this catalyst data set, same thing. Then I'm applying random forest on that. I got the output using digital twin and LLM. I'm getting output like this. If I plot this after 8 iterations or 10 iterations, I got output like this. This is what is my output at the 8th iteration. Digital twin output, right? My energy penalty is 0.75. Deactivation is minimum 0.03 and all that. But my metal ratio is 0.45. This is 6.2. Third parameter is 320 and this is 550. So by using digital twin, my output becomes more stable. If I plot this, I get output like this. I'll just show you in the new tab. See here, this is very important reason, this one. Iteration number 2 to 4, it remains constant. So if I run only 4 iterations, so I'm getting final yield twin around this much, right? If you go for more iterations, again, this is reducing. So as I told you, if you go for more iterations, so we'll have to define the number of iterations and all that, right? So based on the output, what output we get, so we'll have to define the iterations so that we'll get the minimum output and we'll get the maximum yield. Similarly, if I go for the energy assessment, the energy assessment penalty is almost constant. It is 0.75, right? For iteration number 0, it has 0.75. So this is constant. So this is the advantage of using your digital twin. Deactivation risk, again, it is minimum at the 8th iteration, right? It is around 0.03. Iteration number 2, iteration number 3 में वो बढ़ गया था. It is around 0.05 and all that. But at iteration number 7, it has come down to somewhere around 0.03. So this is also better. So it is up to you what type of method you want to use and all that. Whether you want to go for simple machine learning algorithm or you want to go for any agentic AI based algorithm. Right. So hope what I explained from what I explained or discussed from last 1 hour 40 minutes, right? So that is clear. At least you got the basic idea, right? Or the summarized thing that what we are doing right now, right? So by using machine learning algorithm, what type of output you can get. Now, if you go for agentic algorithm, what type of output you can get. Why people have moved from machine learning to agentic AI. Hope that is very clear. So if you don't know about machine learning, deep learning and all that, somebody can say that I don't know about this, right? Yeah, if Elizabeth ma'am is there in the team, right? If she is there right now, I also get the same comment from my better half, right? My or this observer. अभी 2 साल बचे हैं, क्या करोगे ये सब पढ़ के, right? So I'm flowing with the that air, that flow, right? So these things are people are doing right now. Elizabeth ma'am is there in the team. She might be thinking that okay, I'm retired now. What I should do? But this is what people are doing. This is happening in the marketplace. So maybe after few down the line, we may have some product design or innovated by the people who are there in the team and all that. Right? I hope this will be helpful in designing any new product. Right? Now, second parameter, what I want to discuss is chemical process optimization. Right? So first case study was new catalyst. मैंने पूरा detail में discuss किया है. Right? So if any doubt is there, we can discuss it later on. Right? But if you want to optimize the process, right? So chemical process optimization, this can be another case study using again agentic AI and LangChain. So we are not going for machine learning and all that. अभी हमको पता चल गया कि agentic AI यूज करोगे तो बेटर है, right? क्योंकि आजकल वही चला है. तो use that agentic AI, right? So these are the parameters on which this is a problem statement. Optimize a chemical reactor process by autonomously tuning reactor temperature. Sorry. right? Automatically tuning reactor temperature, pressure, feed ratio. Objective क्या है? Maximize conversion oblique yield, minimize energy penalty, ensure process stability, right? Agentic AI enables closed loop self-optimizing process control should be there. तो ये अपना रिक्वायरमेंट है, एक केमिकल प्रोसेस है, उसको आपको ऑप्टिमाइज करना है. What parameters are there in that process? Right? Either you should have your own set of data. If you have your data, then active thing and all that. Otherwise, you'll have to simulate. Now I don't have any data, right? Other data sets are there. So but what I'm doing, I am not tuning my LLM on that data, right? A lot of this type of data is available on Kaggle and all that. So I'm not using that data. I'm going for a simulated data, right? So again, same thing. I'm using the same thing. Mr. AI उसमें से use कर रहा हूँ. I'm using this synthetic data. I'm generating synthetic data by using this random algorithm or the random function. What is how many sets of data I want? Let's say I go for 1000, right? Which is very large number. But as LLM is there with me, so he can do or he can process 1000 sets of data very easily and all that. ठीक है? So 1000 sets of data. Then temperature, pressure, feed ratio कितना होना चाहिए? That I am defining, right? Conversion ये सब. So I got a simulated matrix like this, right? So ये जाने दो. Random forest छोड़ो. I'll go for Mistral AI. So this is my Mistral API key. So what I'm doing, I'm using a chat Mistral AI LLM. Model is the largest one. Temperature around 0.6, right? So then these are my prompt. This is my prompt template. Same thing. वही सब कुछ कर रहा हूँ. मेरा खाली data change हो रहा है, right? Parameters I am going to change. So these are the 3 features which I want, right? Optimization on these 3 features, right? One is temperature. I specified the range and all that. Pressure 1 to 20 bar. Feed ratio 0.5 to 3. Here the pressure plays an important role, right? I think chemical people, you better know this, right? So the pressure plays an important role. So pressure bar is specified 1 to 20 bars, right? Temperature also one of the important parameter, and the feed ratio. So based on that, return only the number, right? Temperature, pressure, feed ratio, मुझे number चाहिए भाई, so that I can compare कि मुझे output बराबर मिल रहा है कि नहीं है. So when I executed this, right, all these iterations, वो जो भी पहले किया तो वो, when I did this, when I run this code, so I got this output. I don't want to discuss the machine learning method over here. I will go directly to the agentic AI method where I'm using a Mistral AI LLM. So I got this output after 10 iterations, right? Around 10 iterations, I got this. Stability penalty is 0 right from the beginning. मेरा penalty 0 है. Penalty should be minimum बोलते हैं हम लोग. So stability penalty is 0 right from first iteration. Initially ये इतना है 15 2.3, right? This has increased to 620, right? Come to 650. Final conversion is 0.5570. Stability penalty is 0. This is what the output I got, right? Means what? If I want to progress that, कि भाई मेरा optimization progress कैसे हो रहा है? So this I got down. Initially it jumped to 0.56, right? Then it reduced iteration number. Again, I will show it on the image in the new tab. So I got this output. So iteration number 8 onwards is start increasing. If I go for more iterations, then my conversion, final conversion may yield, right? So ज्यादा conversion आप ज्यादा iteration run करोगे तो error आपका कम होते जाता है. This happens in all the your neural network algorithms and all that, because we are refining the output, right? इतना नहीं चाहिए, और अच्छा ऐसा, right? Same as out of the frequency synthesizer, right? So frequency synthesizer, what it do? If suppose you want to generate a frequency, means vocal frequency of Lata Mangeshkar. So you can imagine up to what level you will have to tune the frequency synthesizer, because that pitch plays an important role, है ना? आपके आवाज में, मेरे आवाज में, that pitch is not that deep, right? But if you want to generate the vocal frequency of Lata Mangeshkar, so then you will have to do the frequency refining, right, up to the maximum optimized level. So that you can do by increasing the number of iterations, right? So this is how the things works, right? Penalty ratio अगर आप plot करोगे तो it is almost zero, so penalty is showing zero and all that. Next case is if you conversion versus temperature, देखो conversion versus temperature, if you go for 800 also, it is almost same, 0.7 तक जा रहा है, so it is more stable, temperature का issue नहीं है. If you want, you can use the Pareto front visualization also. People are using this, right? You being the chemical people, you know this. I put the explanation of that also over here. Pareto front is used in chemical process optimization. Why? Because my chemical processes are multi-objective. So I want maximize conversion, minimize energy penalty, and minimize stability risk. Right? So that is possible if you are going for if you're using the Pareto front. So Pareto front is a set of solutions where no objective can be improved without worsening another and all that. Right? So this is very important for scale up decisions, industrial feasibility, and sustainability optimization. How it is possible? Simply use that Pareto function over here. So I am using this iteration and I'm generating my response based on that Pareto data. So what a data is there that will be put over here, and then I'll ask my model to predict. So when I ask my model to predict and all that, so I'm using this Pareto data append. Pareto data.append is a function, right? So by using this Pareto principle, I got the output like this. ये stability मेरा zero ही है. Energy penalty देखो है, some energy penalty is there. Conversion is 0.50, 55, it is increasing, right? Almost after 7, 8 iterations or up to 9, it is 0.4 and all that. So if I go for the Pareto optimal solution, I got the output like this. Again, I will show it in a new tab. Two outputs I will be discussing or comparing. One is for multi-objective Pareto optimization, like this. So one output I got, this is one of the output, right? Where conversion versus energy penalty is there. So Pareto is more optimized as compared to all solutions, right? So that's why Pareto conversion method we should use and all that. Second one is energy penalty, Pareto is better. When you go for energy penalty versus conversion, the stability size plays an important role. So all solutions say Pareto is more optimal as compared to the all solution of the general methods. Here also after 3.1 penalty, right? Initially Pareto is better, right? Where the penalty is minimum, right? Here also देखो Pareto is better. But if you go for this energy penalty, if you are ready to pay some penalty in the form of energy and all that, then you will come to know that the Pareto conversion is better as compared to the all conversions and all that. So it is up to you what type of optimization you want to use. You can go for multiple, this one, objective Pareto optimization or normal optimization. So this is the method of, this is my second case study where I'm using the optimization method using Pareto and all that. So basic operation, see chemical process optimization. If you summarize this, you will come to that chemical process optimization can be achieved by using machine learning, right? There RMSE will come to that error is more and all that. Whatever output get, that is not the optimized one. So if you want, means that is not properly refined and all that. बहुत सारा error है उसमें, आपको output मिलेगा, right? But there will be a lot of oscillations, no stability over here, more penalty you will have to pay, right? Temperature will be very high and all that. So you can move to next algorithm. So I skip the deep learning. I directly jump onto agentic AI, right? Because deep learning is also very rarely used nowadays. People everywhere they are using agentic AI only. So I just plot the output of the agentic AI. Then I come to know that the agentic AI gives a better output. Either it is for the chemical process optimization or for new catalyst discovery and all that. Okay. So this is what is my summary which I got just now. So if I summarize things, I got this. What my chart proves and all that. Like learning may agentic AI improves with iterations. We have seen just now. Safety parameter, detailed twin enforces safety operations or safe operation, right? Efficiency wise, energy conversion trade-off is visualized. Intelligence, AI is more intelligent, right? Behaves like a process engineer who knows everything. If you tune it on more large set of data set, So that intelligence will be very high because he knows all the permutations and combinations, right? वो फिर वो कौन था वो some actor, right? That dialogue is very famous. So AI बोलेगा कभी कभी अपन को लगता है कि अपन उस भगवान है, something like that. Then autonomy, no human tuning is required on all that. प्रसिद्धा को बैठ के उसमें ट्यून करने की जरूरत नहीं है. She don't have to change the parameter. All the parameters will be adjusted on their own because you are using a self-learning application or self-learning because agentic AI is self-learning. Only thing is that you have to specify ये भाई तुम ये एजेंट हो, ये एजेंट है, ये एजेंट है, तुम्हारा काम ये, you have to write a prompt, you have to tell him. So instead of one that क्या बोलते gene, we have 3-4 genes over here, right? And all are working on their own. So gene number 1 will give you some, he will generate the data. Gene number 2 will plan the data, and the gene number 2 will test it and give the desired output or the optimized output and all that. Right? So you have 3, just imagine आपके पास में 3 वो चिराग है, 3 जीन्स आपके पास में है, right? So Aladdin, एक ही Aladdin having, imagine 4 genes, 4 that cups and all that, right? Chirag. So you can simply just rush that. उसको आप ये करो, रब करो और आपको जीन आपके सामने आके खड़ा हो जाए. So that is the power of AI. That is what is AI. That's why AI is now dominant everywhere. Then if you ask me, agentic AI is dominant everywhere. क्या चला है तो agentic AI चला है. So if you are not familiar with this, I'll suggest go for it. Lot of data is available, right? So, but basically you should start from the machine learning, then you'll come to know how the AI works and all that. So agentic AI based chemical process optimization. So finally, if I want to conclude, so I can say this much. Optimizes temperature, pressure, feed ratio, maximize the conversion, minimize the energy and risk. I have gone for a less number of iterations. नहीं तो iteration before that, अगर आप if I want to go for more iterations, I'll need more memory, right? So most of the times वो Google Colab आपका crash हो जाता है या आपका reset हो जाता है. So it is up to you whatever hardware you are going to use and all that. Then this is already done. What is chemical process optimization? ये this for understanding. ये छोड़ो. This is a problem definition. We already seen, right? Validation all that. ये छोड़ो. What else? What is digital twin? Also, I am sharing this, right? Digital twin कैसे करता है, right? Why it is useful for process optimization, safe optimization without risk. Second is faster optimization cycles. Then third advantage of that is constraint handling and safety. Fourth is multi-objective optimization. So it is up to you. You have to go for digital everywhere. Nowadays, digital twins are there, right? Integration with AI and agentic AI, real-time process adaptation is possible. So key benefits in the chemical industry, high yield and selectivity, low energy consumption, emission. So we are going for minimizing the energy consumption so that carbon footprints can be maintained. Safety, it should be safe and compliance, right? Reduce downtime and operating costs. Foundation for self-optimizing chemical plants. So if you go for chemical process optimization using agentic AI, you can have these benefits on that. I think these are all ideal things, right? Closed loop optimization will be like this: generate, simulate, validate, decide, and then learn. Learn करके memory में store करेंगे so that the same error cannot be repeated and all that. Then we are I shown the output of the Pareto optimization also, right? Pareto generally used, it has multiple objectives, right? Trade-off analysis is possible if you are using the Pareto optimization, right? Industrially feasible solutions are possible. You better know about this Pareto optimization. You might be studying that theoretically, but I try to implement this using some Python code and all that, so that you can come to know that how good optimization can be, or the optimal optimization can be achieved if you are using the Pareto method or not. These are the benefits, industry benefits, lab. Faster optimization, reduce energy consumption, improve safety, right? Industry 4 readiness, ये सब possible है. Before concluding, right? So I can conclude it like this. Agentic AI enables autonomous optimization, data twin ensure safety, strong potential for chemical industry is there, right? Lot of research is going on. Agentic AI transform catalyst discovery, chemical industry hai. Now you all know that chemical, I'm not talking of destruction or all that. Latest news is that agentic AI, sorry, US is using, China might be using, but US has made it, they have cleared this, right? Or they have said that they are using agentic AI. And basically Gemini, and yesterday only they have signed an agreement with Elon Musk, right? So they want to integrate Grok, their LLM, into their weapon designing, right? So Pentagon is now, previously they had tie up with Google, they're using Gemini, right? Now they come across, they are yesterday only they are signed or launch क्या वो जो भी है. So that lands went to he was there in the Elon Musk yesterday only they have signed an agreement, right? So they are optimizing Grok for the weapon development. US is using it for Pentagon and all that. So that is the application, latest thing, all the latest news about these LLMs and all that, right? So people are doing a lot of research is going on and all that, right? Either in your field, chemical weapons are also there. They might use that. So chemical industry, a lot of revolutions will be there in the coming time and all that. So key enabler for autonomous chemical R&D and all that, right? So again, it is almost 8 o'clock, but I just want to show the output of new drug discovery. I'll just show you the output. आज के लिए बहुत चला है, right? New drug discovery and all that. New drug for diabetes, right? New drug for your this one. And you might have come across that कौन है वो? Pfizer वाला. Pfizer का जो भी one person who has worked with Pfizer from last, because you being from the chemical side and all that, right? Yesterday only I read about him. His name is, okay, he's Peter Rost. He says that I work at Pfizer for 17 years. We didn't discover drugs. We discover markets. So this guy is saying, Pfizer, we assume this to be, वो बंदे ने बैन किया था ना कि भाई हम लोग Pfizer का यूज करेंगे, हम लोग इंडिया का कोरोना वायरस, कोरोना this thing will not use, right? Then Pfizer, now this what this guy is saying, he has put it on the social media that I work at Pfizer for 17 years. We didn't discover drugs. We discover markets, right? See how these people are playing with the lives of the people. If a drug cured asthma in 3 days, we would kill it. अगर कोई ड्रग, अगर हमने नया ड्रग बनाया जिससे अस्थमा आपका 3 दिन में कम हो जाता है या गायब हो जाता है, we will kill that drug, right? Chronic disease is where the money is. Cures are bad for business. Getting? So it is up to the mentality of the company or their policies and all that. But this is a statement given by a person, Peter Ross, who worked with Pfizer for 17 years. And he says that हम लोग नया drug नहीं बनाते. And we are talking of new drug discovery and all that. हम लोग क्या ढूंढते? We research about the markets. ताकि हम लोग हमारी जो भी है रोटी पका सके. ठीक है? So I see I done this same thing you can use for new drug also. And I'll just show you the output. I got this type of output. Agentic AI learning curve. ये देखो मुझे ऐसे कुछ आउटपुट मिला है. After 20 iterations, right? I given some combination. After 20 iterations, I by base standing affinity goes on increasing. Initially it was very less, but as the iteration proceeds, as I iterate more, I got it around 80% and all that. So binding affinity is now better if I go for more iterations. So if I'm using a agentic AI, I think you all know about this, right? 3-4 parameters are important. तो उसमें का एक बाइंडिंग एफिनिटी जो है वो पैरामीटर जब मैंने चेक किया है तो आई गॉट दैट बाइंडिंग पैरामीटर, इट इज इन द इंक्रीजिंग फॉर्म एंड ऑल दैट, राइट? Similarly, I try to plot other parameters also. Organizer, just 5 minutes. Huh?
Yes,
Sure,
sir.
sir.
Yeah. See, when I applied the Pareto ka thing, Pareto logic over there, and all molecules, I got this out. So toxicity, right? Toxicity and binding affinity, you might be knowing about this, right? So toxicity is better when I go for Pareto front or Pareto front, respect compared to other molecules or the all molecules, right? Next thing what I got is, so if I'm using agentic AI, then this thing is possible, right? So binding and all that. So binding affinity, toxicity, and QED. So I'm concentrating on the three parameters, right? So QED, you all know about that, right? Binding affinity also you might be knowing. So I got multiple objective or multi-objective drug optimization. Again, I got, if I'm using toxicity with respect to, I plot toxicity with respect to binding affinity and all that, I'm getting Pareto optimal. Pareto is more optimal as compared to the normal or the all molecules. So you should go for Pareto one. If I'm using the agentic AI approach and I plot this, right? I have three agents over here: generator agent, simulator agent, and evaluation agent. Generator agent को मैंने बोला भी, you will propose the new molecular candidates. Simulation agent क्या करेगा? He will evaluate the binding affinity and toxicity, and the evaluation agent will compute the Pareto optimal values and all that, molecules and all that. So जैसे मैंने बोल दिया भाई, तीन लोग हैं, तुम्हारा ये काम है. I written the code for that. I written the proper prompt for that, and I got this output. After I'll go to the last one, right? After this, at iteration number 9 or iteration number 10, I'm running for 10 iterations only because of my limitation of the hardware and all that. So I got this output, right? What it says, generator agent generating new molecular descriptors, जो मैंने उसको बोला था वो. Planner agent has iterated for 10, right? Iteration number 10 start हो गया, बता रहा है मुझे वो. Now just compare the output of iteration number 9 and iteration number 10. I want only numbers. Now see here, binding is 1.0554, and here the binding is 0.78. So we know that when you're talking of the new drug and all that, you being from the chemical field, right? You know that, or we all know that the binding, lower binding is better, right? Means example, error or penalty. So at iteration 10 is an improvement, right? If higher is better and all that, we can go for, so you can go for more iterations and all that. Second parameter is toxicity. Toxicity, initially it was for iteration number 9. I'm not comparing it with the iteration number 0. आपको चाहिए तो आप 0 से भी आप कंपेयर कर सकते हो. देखो 0 और 10 या फर्स्ट इटरेशन एंड 10th इटरेशन. यहाँ पे बाइंडिंग इज 0.45, टॉक्सिसिटी 7.95, क्यूडी इज 0.30, राइट? 0.30, ये देखो 0.44 पे चला गया क्यूडी, तो टॉक्सिसिटी इज नाउ 7.18. Here if you compare this 9 and 10 का output, so that is also more than sufficient. Then you will come to know that, ये 6.72 था, वो 7.18 हो गया, right? So lower toxicity and all that. Basically, we want toxicity should be good and QED to be minimum. So मेरा QED 0.41, sorry, QED was 0.41, right? Okay, 0.41 to 0.44. So marginal more drug-like properties in iteration on that, right? Slow, slight improvement. QED should be at a higher side, right? Right. So QED should be at a higher side. What is my QED? QED is nothing but quantitative estimate of drug likeness, right? So मुझे जो drug चाहिए, if the QED is more, then whatever output is generated or the combination for the particular combination, whatever output I get, so there my QED is, as my QED is very high, so I am able to generate, or I can have a new drug which is nearly equal to what I estimated and all that, right? So summarizes how drug like a small molecule is and all that. So meaning of QED is composite metric derived, right? From several cyclochemical or physiochemical properties such as molecular weight, then log P. Log P is nothing but my lipophilicity, then H bond, donors, acceptors, aromacity and all that, and solubility. So these are all, you all know about that, right? So some pharma terms and all that. What is HBD? HBD that I mentioned somewhere. HBD is my hydrogen bond donors, and HB is my hydrogen bond acceptors and all that. So if you know, if you compare all these parameters, then we will come to after 10 iterations. So I am getting a refined output, I am getting a good output. So if you go for more number of simulations, if you go for more number of iterations, so then you will come to know that. Then you will come to know that we'll get a drug which is nearly equal to the desired one, right? So if I plot it, I'll just show you the 3 plots. तो मुझे क्या चाहिए, मुझे ये चाहिए, मैं तीनों को कंपेयर करता हूँ, right? So first I will go to the binding affinity. So binding affinity increases with more number of iterations. So this is also better parameter. So affinity मुझे high चाहिए. Second is my toxicity. Toxicity is minimized, right? At the initially it was 9.5 and all that. So it has come down to 20, means, right? So 6.5 पे आ गया. If I go for iteration number 20. Second thing is my QED. QED is goes on increasing and all that. So that likeliness of the drug, the desired output is achieved and all that. So after 20 iterations, right, my QED score is around 0.8 and all that. So 0.8 means 80% of the, my drug is nearly equal to the desired drug. 80% is same, like that. Right. Sorry. चलो, तो ये सब possible है. So you can do this. You can go for new drug generation and all that by using agentic AI. People are using this. So let us come to the conclusion part now. So let me conclude. So what I tried to explain how this agentic AI can be used for chemical process, right? Chemical research and all that. So you can, what we have done, we have, I discussed 3 case studies, right? So first was for the new catalyst, second was for the your chemical process optimization, and the third, थोड़ा सा भागते मैंने discuss किया new drug generation. But I hope that whatever I want to tell you, so I am very clear about that, or you are very clear about that. Clear thing is very simple. तो एजेंट क्या यूज करोगे तो आपको जो डिजायर्ड आउटपुट है वो मिल सकता है. एरर विल बी मिनिमम. सो better, instead of struggling with your machine learning and deep learning algorithm, I'll suggest go for the latest algorithm. Use the proper LLM, right? You can use OpenAI also. OpenAI can give you more refined output because LLM का ये जो मिस्टर AI मैंने यूज किया है, इसका जो भी की है that is free, right? OpenAI जो keys है, these are generated, they are it is a paid version is available. So if you are paying, so you may get some good output and all that. I compared this to OpenAI also. Then I got that OpenAI LLM is better as compared to my this one. Now I came across 2 days back, 3 days back, because when I read about that Boris and all that, he said that he's the person who has written the cloud AI, right? He said that he can run 5 agents at one time using minimum hardware, GPU based laptop and all that. उसने output भी दिखाया है, right? It is available on the this thing. ये ट्विटर पे अवेलेबल है उसका सब आउटपुट जो भी है, उसका लिंक भी है. इफ I can share that link also. But people are doing that, right? Means one पूरा software department is handled by only one person. 5 people, 5 software engineers are replaced by only one code, right? That is operated by one person, like that. So these are the disruptions occurring in your day-to-day life, right? Or disruption in the AI field. Every day something new is coming, right? So it is very difficult for the engineers also. Now last thing is the topics where you can do research and all that. So people are using this. Maybe down the line I'll generate some I'll write some articles on it and I'll post it on the LinkedIn, right? So agentic AI and autonomous chemical systems, self-driving chemical plants using multi-agent AI system. So all this is possible, right? Because if you are going for autonomous chemical systems and all that. So here there's a scope for doing research and all that. Okay, human in the loop, agentic AI for chemical engineering decisions and all that. Cognitive chemical manufacturing enabled by agentic AI. Closed loop agentic AI for chemical process designing and scale up. So in this field, research is possible. If you want to go for catalysis and reaction engineering, these are the fields where research can be done. Self-optimizing catalytic reactors, right? People are doing this right now, powered by agentic AI. It's everywhere agentic AI is there. So people have moved from machine learning to agentic AI with, now we are talking about the industry 4 and all that, right? Somewhere people are talking about industry 5, right? Where all operation will be handled by agentic AI means all operations will be handled by more robotic processes can be there, right? So we don't know what will happen in the near future, but this is what is happening right now. Here, research is there, people can do. In green chemical technology also research is possible, so people can go for that. So I'll be sharing this later on, but this is what is going on right now in the marketplace, right? I listed few of the applications. These are some of the emerging frontier topics and all that. In fact, my 3 articles are ready on this, right? So maybe that data I have not added in the articles, comparison and all that. So maybe by Sunday, 4 articles on this, what a research topic I told you just now or discussed just now may be available. So you can go through that, right? So it will be available on the LinkedIn. मैं मेरा कुछ marketing नहीं कर रहा हूँ, but if you want, because people are there, most of the students, they are not familiar with agentic AI. There is a complaint from the students, same maybe from the chemical people also. कुछ chemical students जो है जिनको मैंने BEE पढ़ा है, they are also joined that. They are subscribed my this thing, my templates and all that. So there I come, some few people are there, right? So around 1,500 subscribers are there, with whom I am regularly having discussion on LinkedIn and all that. So choice is yours, right? So thanks for patiently listening to me, and what else? Let me come to the. I'll stop this. Okay, किधर है? So 104 people are there. I'll stop. Right. Prasida is there.
Yes, sir.
Yeah.
Thank you.
So yeah. Thanks for inviting me, right, and patiently listening to me, and thanks for
Thank you
being
very
on the
much,
other
sir.
side of the my say screen and all that, helping me whether my screen is visible or not and all that. You might have taken a clip of this. You can share the later on, right?
Yes, sir.
आपने ये लिया इमेज लिया है, पिक
Yes,
लिया
sir.
है? Yeah.
हाँ सर, रिकॉर्डिंग भी है.
Yeah. नहीं, this image, right? Around 102
Ye-
people are there. जितने भी होंगे, जो भी है,
Yes,
so
yes.
you can share me
Yes, sir.
later on, right?
Sure, sir.
Yeah. So thanks for
But
being there.
so
Thanks guys for patiently listening. Bande sir, Trupti ma'am, then Mr. Kamkar, then
Yes.
Akruti, then Siddhi Vora, Mihika Gupte, and Hitan Shah, Baki, and other members, right? So hope whatever I want to explain or whatever I discuss, you at least got 50% of that. Remaining 50% you'll have to learn, right? So unlearn something and then you learn this thing, so that, and happy agentic AI coding, right? So happy. I hope that this will help you in understanding the concept in more detail, so that more research can be done by you people and all that. Oh, Trupti is clapping for this.
Yes. Okay.
यानी तृप्ती म्हणत असेल की हो गया एक बघा झालं सर संपवा आता.
Very
ठीक आहे ठीक है.
Nice, sir. Nice, sir. No,
Thanks.
sir.
नहीं, it's okay. Just
It was
joking,
very
kidding.
insightful, sir.
क्या हो गया, 2 घंटा
Yeah,
हो गया
sir.
ना. So I am again conducting the online course.
Uh,
It is very difficult. We don't know who is there on the other side of the screen and all that, whether he's acting or not. But I
Right,
have to
sir.
do my duty, right? So as Prasida said, I tried
Right,
my
sir.
best to explain the things in a very simple way and all that, right? So somewhere I
yes,
added
sir.
Bombay
Yes, sir.
examples also. So happy
Yes, sir.
learning. Right.
So participants, if you wish to ask any questions, you can either post it on the Q&A section or unmute yourself and ask.
See, I'm available on the my email and WhatsApp also. You can share my number. They can contact me
Yes,
later
sir.
on.
You can, yes, participants can contact us if you wish to get in touch with sir for your studies or your research projects in agentic AI.
Julie. Lot of experts are there. I am one of that, right? Because FDPs and all that, I want to post it on the LinkedIn and all that. Yesterday night, I received one call from some Saraswati, which है not Sar, it's कुछ तो one Bengal University का one lady is there, some Soumya Datta. She asked me to give because they are also arranging some FDP in February and all that, right? I don't know about that university, that's some Bengal ka university, but from the LinkedIn also she got the link and all that. She sent me a mail कि सर आप keynote speaker ban ke aayi and all that. She asked me to come offline. Let's see how things moves and all that. So maybe that will help in other people also. That's it from my side.
Definitely.
चलो बहुत बोल लिया.
Okay, thank you. So I'll proceed with the concluding the session for the day. On behalf of the organizing team, I sincerely thank Gopal sir for the excellent talk on agentic AI driven autonomous catalyst discovery. As I mentioned in the introduction, sir has presented a highly complex topic in a very clear and simple manner, making it easy for all of us to understand, even though it was the online mode. Sir has effectively explained the importance of agentic AI, different types of AI models, and how AI is already an integral part of our day-to-day activities. The discussion on new Catalyst discovery, including its steps, applications, and overall architecture, provided us with a strong conceptual foundation of the topic. The role of generative AI, along with the case study that Sir has discussed specifically on the new drug development, which we all can relate to, uh, has along with the practical demonstration of it, clearly illustrated how these ideas can be applied in research in actual research. This talk was highly informative and valuable for both teaching and research in chemical engineering. We truly appreciate your efforts and your willingness to share your knowledge with us, sir. We sincerely hope to have many more insightful sessions with you in future, which will help us gain a deeper understanding of such a complex topic, agentic AI, and its
I'll
applications.
yeah, I will suggest go for offline sessions.
Definitely,
Yeah.
sir. Thank you once again for a wonderful and enriching session, sir. So
Yeah, thank
I
you,
would
ma'am.
like to I would like to conclude it for the day. Thank you,
Yeah.
participants, for being patient and being there with us. Thank you.
I'll
Thank you,
I'll
everyone.
share the PPT in just few minutes, right? I'll WhatsApp it
Yes, sir.
to Ramesh sir.
Sure, sir. Yes,
Yeah.
sir. Yes. Okay. Thank you, sir.
Okay. Thank you.
Thank you, sir.
Thank you, ma'am.
Thank you, Ramesh, sir. Thank you, Neeta, ma'am. Thank you, Bande, sir, for being there. Thank you. I'll end the meeting.